2. Listen to part of a lecture in a zoology class.
Okay, class, before we get started, I wanted to remind you that your midterm is on Friday, and I am available in my office every afternoon in case you have questions. Now, today we are going to discuss birds and one of their most intriguing behaviors, migration. Now, as you all know, many different bird species must migrate in large flocks whenever there is a significant change to their environment, usually when it gets colder or when food becomes scarce. Seasonally, some birds will migrate over many thousands of miles to reach their destination. Any sailor or pilot can tell you that you need some sophisticated tools in order to navigate your way over such a long distance, and birds are no different. So, how do these birds get to where they're going? Well, there are plenty of ways. One way birds navigate is by using the sun as a reference point. By determining the position of the sun in the sky, several bird species gain a sense of direction, much like sailors. In order to do this, birds have a sort of internal clock that helps them keep up with the changing position of the sun. Two types of experiments have confirmed this. In one, birds were observed to have trouble establishing a clear flight path on cloudy days. In another one, a group of birds was kept under artificial light for several hours. This messed up their internal clock. So, once released, they miscalculated how the sun had changed position in the sky, and they significantly strayed from their flight path. Another simple way that birds navigate is by reading the position of constellations. Obviously, this is practiced by nocturnal species or birds that only migrate at night. Much like ancient sailors, these birds determine the position of these constellations in order to find their appropriate flight path. In one experiment, pigeons were kept in a planetarium, where a dome with an artificial nighttime sky can be rotated. Scientists kept changing the position of the constellations seen, and the pigeons inside adjusted their flight patterns to match these changes. But one of the most impressive things we've learned about bird navigation is that they are somehow able to read Earth's magnetic fields, thus being able to determine direction. We don't really understand the specifics behind this, so there are a couple of theories out there. Some believe that birds, like most organisms, contain magnetic compounds like iron oxide in their bodies. This would allow them to detect fields coming from the north and south poles, thus giving them a sense of direction. However, many scientists have argued that birds must also be able to detect weaker magnetic fields in order to accurately follow their flight paths. This cannot be done by simply having iron oxide or other magnetically sensitive materials in their body. Thus, there are some other theories about how birds detect magnetic fields, and some of these ideas are very complex. Nevertheless, they are worth exploring.